The ability of natural dyes to color textiles has been known since ancient times. The earliest written record of the use of natural dyes was found in China, dated in 2600 BC. Chemical tests of red fabrics found in the tomb of King Tut in Egypt show the presence of alizarin, a pigment extracted from madder. The plant pictured above is a madder plant, and the roots of this plant are used to create the red dye that was once used. In ancient Rome, marine snails were collected by thousands to make Tyrrhenian purple. Here's a short video on that process.
Once, this now crumbling port in northern Israel was vital to ancient fashion. 3,500 years ago, Dor was the site of a thriving dye industry based around this tiny snail.
Good.
Researchers have only recently rediscovered how the ancients made dye from the snail's glands.
We then take that dark purple liquid, dry it out, grind it up. Basically what we have is the raw dye in a very concentrated form. Chemically, we're talking about something called dibromo-indigo.
A researcher discovered the chemical reaction when the fishy smell became unbearable and he put a flask by a window. The biblical blue dye, tachelet in Hebrew, was once used to color the ceremonial robes of pharaohs and emperors. Today, the thread is woven into prayer shawls. Tachelet was once worth more than its weight in gold. It's now a precious link with the traditions of the past.
The purpose of this lab is to demonstrate 4 methods of natural dyeing on different types of fabric and then evaluate the effectiveness. I use these 4 natural substances as my dyes: turmeric powder, purple cabbage, red onion, and black tea. The first step of my procedures was to prepare the fabric for dyeing. You must soak the fabric in hot water and use a mordant or fixative such as salt, cream of tartar, or alum. Alum is the hydrated form of potassium aluminum sulfate. It has many uses, but today we are using it as a mordant. A mordant is a substance used to set dyes on fabric by forming a coordination complex with the dye, which then attaches to the fabric. It may be used for dyeing fabrics or intensifying stains in cells or tissue preparations. After soaking the fabric, you must prepare the dyes that you're going to use. The first thing I'm going to do is dye the fabric with cabbage. Add water to the cabbage and then boil for 45 minutes, stirring frequently. Next, drain the cabbage, but collect all of the juice in a bowl below the strainer. Let the fabric soak in the juice for up to an hour.
Yeah, that one actually has dramatic.
Rinse the fabric thoroughly after it has been soaking for the allotted time. You can tell right off the bat that one of the fabric strips is much lighter than the others. This is the polyester, the synthetic fiber. The others are made of natural material. After a thorough rinse, the cabbage dye seemed to have faded from most of the strips of fabric. However, when observed up close, the linen is a faint lavender color, while the other fabrics are closer to white. Using the same process as before, dip the fabric strips into the dye and submerge completely. After 30 minutes has passed, rinse the strips thoroughly with cold water. The results of the turmeric experiment were much more vibrant than the cabbage. However, you can still tell that the polyester fabric is more dull than the rest of the fabric strips.
good, it's good.
But it's more.
This is gonna get really
Based on my observations, synthetic fabric such as polyester does not absorb dyes well. The other three fabrics, however,
should put all the
resulted with
things on.
very vibrant colors.
Oh yeah.
My personal recommendation for you would be to use cotton if you were dyeing an article of clothing. Even the linen, which seemed to be the winner for the brightest color, was not very soft and even may be itchy on your skin. Rayon, on the other hand, is slightly softer than cotton, but if you accidentally put it in the dryer, it will shrink a large amount and ruin your garment. Therefore, cotton is the best material to use when dyeing. Cotton and linen fibers are both natural fibers made from cellulose, a compound found in cell plant walls. Fiber-reactive dyes form permanent covalent chemical bonds with cellulose, making this dyeing process a relatively permanent one. Polyester, however, is a synthetic fiber that does not react with fiber-reactive dyes in this way. In order to dye polyester, a great deal of heat must be applied during the dyeing process, and specifically designed dispersion dyes must be used. Because I did not use this method of dyeing in my experiment, this explains why the polyester fabrics were significantly lighter than the plant-based fabrics. Covalent bonds, which share electrons, are one of the most basic and strongest types of chemical reactions. The reason I used hot water was to speed up the reaction. In today's world, we all purchase and wear clothes. Clothing that we buy is made from a variety of materials such as polyester, cotton, nylon, rayon, and even wool. Manufacturers have to pay close attention to the types of fabrics they are using and the dye that they are using on the fabrics. If the correct method is not used, then the dye will fade and customers will complain.